Dear students, welcome to this DT session. So we discuss about a DT on conductometric titrations. Usually in laboratory or in any theoretical experiments, we do some reactions that basically based on a traditional volumetric analysis. But in volumetric analysis, that exists some demerits. So we can go for some other technique like conductometric titration instead of that volumetric one. So our jobs here is now to discuss in the design thinking aspect about the conductometric titration. Yes.
Sir, so we have the first pillar as empathy. It is to understand users' feelings, emotions, and their needs. So, as per our problem statement, empathy can be accepted as when we use old traditional methods, there can be manual errors and so on, and the color will not be visible properly. There will be complex problems. Also, when it comes to visual indicators, the color change is also not visible that clearly.
And the endpoint will not be sharp.
Yeah.
Yes.
In volumetric titration, the calculation of the endpoint will be this will not be clear in the
For the colorless
colorless
solutions, yes, it would be different.
In volumetric titration, it is difficult to find the endpoint of the precipitation solution.
That means precipitation titration. Yes, good.
Yes. By continuing the empathy, and the second pillar is define. This define is which means the giving the solution for the proper defined problems. So we have taken the ancient method problem to convert it to a conductometric titration. Am I right? So in the conductometric titration, students are needed accurate and proper points to be plotted in the given graphs. So the ancient method is not that much accurate, but by using the conductometry we can get the accurate points and the endpoint also will be visible.
I can say this. Using an instrument, we are arriving a result with the graph.
Yes,
So it
sir.
will be more accurate than what
Than
you expect
manual.
in manual calculations.
Yes.
Yes.
And third pillar is ideate. Ideate is nothing but generate ideas to solve the problem. The first idea is using sensor to detect chemical changes, and second thing is measure electrical conductivity to trace ion concentration, and third is developing conductometric titration as an alternative.
So the fourth pillar is prototype. Prototype is nothing but the experimental setup of the following conductometric titration. First we'll be having a beaker, burette, and conductometric titration things, and a conductometer. We'll be having a platinum electrode to measure it, and we'll be having the analyst like NaOH, HCl, and NaOH will be filled in the burette and HCl will be in the beaker. So the electrode will be immersed in that beaker. By stirring it, we'll be having a stirring rod to stir it. It will be the electrode will be connected to a conductometer. So while titrating the burette, drop by drop, we'll be stirring it with the electrode, glass electrode, and finally we'll be getting the endpoint shortly. Yes.
And the cell point must be 1 ATM. It is very important to be kept in one, because the platinum electrode which contains 1 ATM, which uses to get the accurate points to be plotted at the graph.
Awesome. Awesome.
So let us conclude this session. So from this problem we have understood that than the volumetric titration, conductometric is found very useful. Also, as he said, precipitation reaction, colors are not recognized that clearly, but in conductometric colors are seen visibly, and it is more useful than the volumetric ones.
So as the continuation, we will be plotting graph between conductivity and the volume of the titrant. So by this we can we can clearly see the endpoint sharply by plotting the graphs.
Saying that manual error can be
Reduce.
because we are depending on more instruments and graphical methods. So it's a nice session. Thank you, students.
Thank you, sir.